honors algebra students. Mr. Lawrence here with your review lessons for the final, and I've got to apologize. A decision was made without me knowing it, without any consultation by me, while we were in Washington, D.C., and it turns out the only class you're going to have with me before the final is Tuesday's class. So if you watch these videos and you got it unchecked, you'll know that. If not, we won't be meeting as a class Wednesday. I will be able to offer after-school help on Tuesday. I will not be able to Wednesday. Unfortunately, I have a doctor's appointment. All right, so I'm going to try to make these videos as good as possible to help you get ready. You can always go back and look at old videos. You can do sample problems from the book, etc. But of course, you'll have the review sheet on Tuesday if you don't already have it. But I apologize. I had nothing to do with the fact that we won't be meeting as a class on Tuesday, or excuse me, on Wednesday. All right. First of all, Chapter 8, Laws of Exponents. Real simple stuff. Remember that like 2 to the 4th is not 8. It means 2 times 2 times 2 times 2, right? Which will be 16. When I have a problem like this, say 5x to the 3rd times 6x to the 7th, well, 5 times 6 is 30. X to the 3rd times x to the 7th, well, there's 3 x's being multiplied together. There's 7 x's being multiplied together. So there must be 10 x's being multiplied together. All right, the shortcut is 3 plus 7 is 10, right? When you're multiplying exponents. When you're dividing, say you have 20x to the 6th divided by 5x to the, 4th. Well, you do 20 divided by 5 and get 4. X to the 6th divided by x to the 4th. Well, that's going to be x squared. The shortcut is to subtract. Look, wouldn't it look something like this? X to the 6th over x to the 4th. And then you'll remember that these cancel out. And I'm left with x times x in the numerator, which is the same as x squared. Okay, now, remember that on negative exponents, negative exponents mean use the stairs. And what that's saying is if I have x to the negative 3rd, that's the same as 1 over x cubed. If I have 1 over x to the negative 8th, that's the same as x to the 8th in the numerator. Okay? They get more complex when you have problems like this. Say 125, x to the 6th, y to the negative 2nd, z to the 5th, and that's all going to be over 5, x to the negative 3rd, y to the negative 8th, z to the 10th. Okay, well, my numerator is going to have a 25 in it. This x to the negative 3rd is going to go upstairs and become positive and combine with an x to the 6th to become x to the 9th. These guys are going to switch places, giving me a y to the 8th in the numerator and a y squared in the denominator. But that, of course, will simplify to just y to the 6th. All right, and the z to the 5th over z to the 10th will result in a z to the 5th in the denominator. And my simplest answer would be this. Remember that whenever I do this, I always want to make sure that I have no negative exponents. Okay, now one thing kids get confused all the time with is something like this. 5x squared y z to the 3rd. And I'm going to cube that. Okay, one thing I advise you to do is slide that little 1 there. That exponent on y is a 1. Okay, 5 cubed is going to be 5 times 5 times 5. You see this cube? This is like 5 cubed. Yeah. And then this x squared is being cubed. And the y is being cubed. And the z cubed is being cubed. That's a long way of doing what I'm going to do. Well, 5 cubed is 125. All right, x squared cubed. That means x squared times x squared times x squared. Well, that's the same as x to the sixth. Some of you notice that you just do 2 times 3 to get 6. And that is very well true, but be careful. Some of you will get that confused with multiplication. That's not multiplication, that's an exponent. It's a different rule. All right, y cubed is, you guessed it, y cubed. Z cubed cubed will be z to the 9th power. And there you go. All right. Once you've mastered that kind of stuff, it gets pretty easy to deal with most of the other problems. Now, one other thing from chapter 8 is scientific notation. Okay, now this should be simple stuff. First of all, we have to convert to psi naught, and we might have a number like this. Let me make that a 0. Or we could have a real small number, small positive number, like that. Okay, well, to turn this into scientific notation, I'm going to divide it by a power of 10. What power of 10? Well, I want the decimal point, which is right there, to end up being after the first non-zero number. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to get 3.65 times 10 to the 9th power. I divided the 3,650,000,000 number by 10 to the 9th. So therefore, I have to multiply 3 and 65/100 by 10 to the 9th. Okay? And down here, I need the decimal point to go there. 1, 2, 3, 4, 5. So I'm going to have 1.47. I'm going to multiply it by 10 to the 5th. Negative 5th, that is. Okay? So you see this number here got quite large comparatively. And so I had to multiply by a negative exponent. Whereas this number here got quite small, comparatively speaking. And so I had to use a positive exponent. Now remember, your number for scientific notation is always going to be like 1.0 times 10 to some power. And it's going to be smaller than like a 9.99. Okay, it's always going to be between those two numbers. Now, when you have to add, subtract, multiply, or divide, I advise you to use your calculators. Your calculators are great for this kind of stuff. Just put parentheses, 3.25 times 10 to the 8th plus 1.63. Oops. That's my back button. Times 10 to the 3rd. See, right now you can't add these together because the exponents don't match. Your calculator is programmed to know that, and it'll take care of converting them for you. If you have a multiplication situation, you can just do like 5.31 times 10 to the 2nd and 1.5 times 10 to the 8th. And again, your calculator will handle that for you. You can just simply multiply these two numbers together, multiply those powers together. Make sure your answer is in scientific notation. If it's not, you have to convert it back. Okay. Let me see here. Two other things from Chapter 8 that you need to know. One is exponential growth and decay. And you have a formula for this. And I believe the formula on your review sheet is incorrect. And I caught that after I had made all my copies. But this should look familiar. Remember that P is the principal. And that's the money that was invested. Okay. R is the rate as a decimal. Okay. T is the time in years. And then A is the amount of money after T years. Oh my goodness. I'm not sure what word that is. Let me try that again. And I'm not in right mode. Okay, that's the amount after T years. Okay, those problems should be really simple. Just plug and chug. For example, if you know a town has a population of 10,000 people, it's growing at a rate of 6% per year. How many people will be in the town, say, in 20 years? Okay. Now, when you go to plug it in, it's going to be A equals 10,000 times the quantity of one. It's growing plus 0.06, and the time is 20 years. And you can go to your calculator for that. Hold on one second. Now, your calculators are much more user-friendly than mine. Okay, 10,000 times the quantity of one. Oops, it didn't take it. Okay, I think it's working now. Raise it to the power of 20. And I did something wrong. Hold on one second. Let me get a more user-friendly calculator. Okay, I think I'm just going to use Google because it's pretty easy. Type in 10,000 times 21 plus 0.06. And that'll be the 20th power. And there you go. You see my answer is right here. Looks like there'll be about 32,071 people. Okay. One last thing we need to know for Chapter 8, and that would be graphing. And then I'm going to wrap this video up. I know I said I do Chapter 9 here, but I'll make Chapter 9 a separate video. Let me get a graph out here. Okay, so got to learn how to graph something like this. And I remember a lot of you don't remember because it's been too long. Let me point out you can go to coolmath.com/graphit and make sure you're up to date on your Java because that's what it uses. And then you can type it in there to know if you did it right. But let's see if I can refresh your memories here. We'll use a t-table just to kind of figure out what's going to happen. Oh my goodness. Hopefully that looks like a y. And I'll pick some values for x and y. And let me see here. Let me make go -2, -1, 0, 1, 2, and 3. Okay. Well, I'm going to start here. It's a little bit easier. 2 to the third is 8, plus 1 is 9. 2 to the second plus 1 is 5. 2 to the first plus 1 is 3. 2 to the 0 is 1, plus 1 is 2, right? 2 to the negative first. This is not a negative answer. Remember, a negative exponent means use the stairs. 2 to the negative first equals 1/2 plus 1. That'll be 1 1/2. And 2 to the negative second would be Well, 2 to the second is 4, so it'd be 1 over 4, 1 and 1/4. Remember, there's going to be an asymptote going on here. I believe the asymptote is going to be at y equals 1, right? And if I plot these points, and let's see, there's the origin, x-axis, y-axis. At 3, I'm all the way up at 9. Oops, that's off 1, but that's okay, I can fix it. Alright, at 2, I'm at 2, 3, 5. And then at 3, no, at 1, I'm at 3. Okay, and at 0, I'm at 2. And then I'm going to end up at 1.5, 1.25. And you can see, if I can draw it, this is always so difficult to do on here, but it's going to do some, yikes, something like this. Oh, I missed that pretty bad. I'm sure Andrew will let me know about that. All right, something like that. And maybe I can do it in a highlighter. There we go. All right, I'm doing the best I can here, ladies and gentlemen. We know it won't cross that imaginary barrier. How do I know that's an asymptote? Because there's no way I'm going to get a negative value out for this. If I continue to put large positives in, y is going to become a larger positive. If I continue to put negative values in for x, the 2 to the x power is going to become smaller and smaller and smaller, but always stay positive, become a smaller fraction. For example, 2 to the 6th is what, 64, I think, right? 8, 16, 32, yeah, 64. Okay, 2 to the negative 6th isn't negative 64, it's 1 over 64, which is a really small decimal. You know, it's approaching 0. I'm going to add 1 to it. So no matter how small I go, like x is negative a million, the 2 to the negative millionth power would become a tiny, tiny number, like 0.0000000000000, whatever, and then I'll add 1 to that. So I know this is the graph of it. Okay, I know that was really quick review, but we got to get through these. I'll put up this one soon, and then chapter 9 as well. All right, Mr. Lawrence signing off.